Boom. And we're live. Hi, everyone. Thank you so much for joining us for Stripe Dev Chats. My name is Cecil Phillip, and I'm joined with my colleague Charles. And we have a special guest today who's going to talk to us about something really cool. So Luke, before we actually talk about the topic, why don't you tell us a little bit about who you are and what exactly you do?
Sure. Hey, everyone. My name is Luke Edwards. I'm a developer advocate at Cloudflare. I specifically focus on the Cloudflare Workers team, but that, as we'll find out, covers a bunch of products that Cloudflare offers. Before joining Cloudflare, I have used Workers for a number of years, and for a long time thought it was my secret sauce when doing client work and consulting work. But I am now very happy to talk about and share the secret sauce publicly. So worked out really well. I'm really happy to see the Workers product and the entire platform grow and evolve. We will see some of it today together, but yeah, if you're not familiar, check out cloudflare.com, look for the Workers product, and there's an entire fleet of products available to you today to get started with.
You know, it's funny you said secret sauce, because I feel like for some reason, every time we're on the show, we start talking about food. And they always do it. So it's 5 o'clock Eastern Standard Time, my time. I know you all might be in different time zones, but I know right after this, the first thing I'm going to do is I'm going to go get some food. But you've already started talking about secret sauces. I mean, we're gonna have to talk about that.
He ain't gonna make it through the end of the stream.
I don't think I can. I don't think I can do it. I don't think I can do it.
I just scarfed some pizza right before they started, so I think I can hold over for a little bit.
This might be the last time you come on the show. I'm playing. Okay, so I really want to talk to you about Cloudflare and Workers and like some of the other cool things that you all are doing over there. Before we do that, Charles and I are going to go through some quick highlights just to let folks know about some of the cool things that have been happening in the world of Stripe. So I'm going to pull up my screen really quickly, if I remember how to do this. All right, so first link we're going to share with you. Folks may not know this, but Stripe actually supports hardware. Yes, we do. That's a thing. And one of the products that we do that through is called Stripe Terminal. You can think about, imagine you have, you're walking around the store and you have like these little devices in your hand where you could accept payments, you can process credit cards, and you don't necessarily have to walk to the register or walk to like that little checkout area inside of whatever store you might be in. So we enable that capability from a software perspective and also from a hardware perspective using Stripe Terminal. And it sounds like, I believe, we have a lot of new features in there. So Charles, do you want to talk to us about that really quickly?
Totally.
Tell us what's new and cool in the world of Stripe Terminal.
Yeah, absolutely. So Terminal has a bunch of new stuff that has come out recently. Over like the last few months, we've had the M2 reader, which is like a Stripe created device. But the newest and greatest integration is a server-driven integration path that allows for the tabletop readers, because we have two types of readers. We have the mobile reader that you talked about, Cecil, and then we have like the traditional tabletop reader. There's now an API-only integration path for the tabletop readers, and that's super cool. You don't need to rely on our client SDKs or anything like that.
Nice. That sounds awesome. So if folks are interested in building like those types of integrations inside of your applications, definitely make sure you check out our docs for Stripe Terminal. And I'll make sure I drop these links inside of the comment section so y'all can take a look at them and browse them as on your leisure. Now, next link we want to share with you. Recently, we had a new teammate join. Her name is Charlie Gerard. And Charlie's been writing some amazing blog posts about her experience as she's been like starting to build a lot of cool stuff with Stripe. And this first one I want to share with you is called Try Before You Buy, Adding a Trial Period to Subscriptions. And this is available on Dev2 underneath the Stripe organization. Now, what's cool about this is, let's say, imagine you have like some subscription service, but before I want to really commit to your service, maybe I want to have like a trial period, like, try this for 2 weeks, for 5 days or whatever the case is before you actually commit. Well, Charlie kind of walks you through the process of how you can actually do that using Stripe and using Stripe Checkout. So again, definitely make sure you go ahead and check this out. This is over on Dev2. Another blog post from Charlie is called Request Payments Anywhere, Anytime with Payment Links. Now, for me, I don't know what everyone else thinks, but I think payment links is one of the easiest ways that you could accept payments using Stripe. You literally just create, a little URL, and it'll have a lot of your information about like the products that you want to sell, and you could, put in your checkout forms and all kinds of stuff on it. And so, again, in this blog post, Charlie kind of walks us through, well, what does it look like to actually create a payment link? And she shows us, using the Stripe dashboard, how you can do this with almost absolutely no code at all. And if you wanted to, you could write code too. So it's like no code, but a little bit of code. It's like low code, right? It's kind of like in the middle. So you can kind of pick and choose like the path that you want to take. But again, just kind of shows you like how easy it is for you to get started, to start accepting payments from, using something like payment links. All right, our next two ones are videos, and they're actually mobile focused, which I think is pretty cool. This particular episode of the React Native show, they talk about how we could use some of the new payment elements and things of that nature inside of a React Native application. So I think that's pretty cool. It's on the Call Stack Engineers YouTube channel. So if you're interested in checking that out, go ahead over there and take a look at that. And then also the folks at Superbase have also been talking about how we could build, Stripe-enabled applications using React Native, but then also using their backends, where I think Superbase has like a database service and a worker-like situation also in the background, which is pretty cool. So if folks are interested in learning about these things, again, go ahead and head over to the Superbase YouTube channel, where you could, subscribe to their channel, support the cool stuff that they've been building, and learn how you could build integrations also with Stripe. Now, enough of that. We are going to switch over now, and we're going to talk to Luke. So, Luke, the first thing I want to ask you is, if, as a developer, I've always thought about Cloudflare as a DNS company, right? Like I go there when I need DNS for my application, or I want a CDN type situation for my application. But that's not what you came to talk to us about today, right? We're going to talk about pages and workers. So could you give me like the quick pitch? Like what are these things? What do we use them for? Why does Cloudflare care about like building like these types of products?
Sure. So I think your initial assumption about, or initial thought towards Cloudflare is fair and is very common, right? Like Cloudflare traditionally has been DNS, has been CDN, right? But for both of those to work, Cloudflare has to establish a global presence that is very quick to respond, and capable of very high throughput. I forget the exact statistic, but Cloudflare handles an obscene percentage of, the internet through DNS, through cache, whatever it is. So we are everywhere, and we are handling a bunch of the traffic. So the next evolution of that, if we have a bunch of stuff being cached through whatever origin servers, whether you're using your own hardware or AWS or GCP or Azure, whoever, right? And we're basically glue code between you and the client. Well, why can't we also be the origin servers themselves? So we utilize the exact same network, all the same points of presence that handle DNS, that handle cache, that handle everything you know and love about Cloudflare to power workers. And that if you're coming from one of these other cloud providers, that is the AWS Lambda or the GCP function equivalent. So workers is a, functions as a service platform, right? Where you write the code and Cloudflare will put it everywhere for you and execute it. So again, another stat that I probably should have tattooed to the back of my hand, but Cloudflare, there's a Cloudflare point of presence within 100 milliseconds of 80% of like internet users. So it's again, I think it's actually more impressive than that, but I don't want to say a higher number and be wrong, but it's at least that. So that means that users everywhere in the world can access and run your code very, very physically close to them. Again, that's because there are physical points of presence all around the globe, all running your code, and you don't have to manage or orchestrate any of that, which is amazing. So again, a direct comparison coming from a Lambda or a functions universe, typically those run in a single region at a time, right? And if you want to run them in multiple regions, you can, but you have to manually tie them up with a bow so that you can have, geo IP filtering and like route it to the closest active region. And you get all that for free, and functions workers themselves are very, very cheap with a pay per execution model, or a pay per execution and a gigabyte CPU model, but you can choose depending on your workload. And we're talking 50 cents per million invocations at like the highest billing price.
That's pretty good.
So yeah, it's very cheap. Again, secret sauce for a reason. Like I was powering a lot of complex client applications, my client applications for very, very little dollars, which probably is not something I should say, but that is the reality where a lot of people are just being able to do so much because of Cloudflare for so little, especially compared to Cloudflare's competitors.
So I'm really curious to see what this looks like. So why don't we take a look at your screen maybe and see what it feels like to like set one of these up and kind of get started.
Yeah, I do have one quick question though. While you're doing that, Luke, like what's like startup time? So because I keep whenever I hear about Cloudflare, it's like fast, speed, et cetera, coverage. Like how fast are Cloudflare workers? Like what's the startup look like?
It is 0 millisecond startup.
Nice.
So like we're talking microseconds to start up, and that's because workers themselves are using V8 isolates. So like we have Chrome, we have Node. Those are both powered by V8 under the hood. There are spinoffs here and there, whatever, but the biggest JavaScript engine is V8 itself. And V8 internally, this is kind of where my knowledge stops. V8 internally does have this concept of an isolate, which is basically, let's call it a mini executable, JavaScript executable point in time that is just ready to go. So in the typical sense of a JavaScript execution, right? You download the Stripe SDK from some CDN in your browser. You download it on your page. There's download time that goes into part of it. There's then parse time, and then there's evaluation time, and then it executes, right? But the isolate is like a more WebAssembly-ish, where it's already been parsed and evaluated. So like it just has the information ready to go and can just like do the thing. And so Cloudflare keeps these isolates all around the globe ready to go, ready to do something, so that when you actually get an HTTP request or a scheduled cron job event or anything coming in saying like, hey, I want this isolate, it's already ready. It's just going to run it. So yeah, very, very fast startup times. Like it's not perceptible to the end user at all. So it is an instant startup.
So and that's a really good question, Charles. So like I've used Azure Functions before, and I've seen other folks have like their functions as a service thing. And I know cold start is always an issue. Like when you start a scale really big, and particularly to even after you're doing like updates and stuff like that, and you have to, start updating the different nodes within like, your serverless farm, right? Like the servers that you don't see. That takes time. So what you're telling me, like I want to make sure I quote you correctly. What you're telling me is that you have almost instantaneous startup time, like no cold start, deploy, yes. Go, I'm ready.
Yes. So deploying a worker, it will propagate and be done. It will be serving your new code within a few seconds. But once it's been propagated and it's everywhere, the time of the only time the user will be waiting, like, from the browser, is the time it takes for them to connect to the closest pop location and to execute the code and come back. It's like there's no traditional cold start like you would have in a Lambda or a function model or an Azure model, right? It's there, it's ready to go.
That's very cool. Okay, cool. Well, let's go ahead and take a look and see how this stuff works.
Cool. So we're going to jump into an existing worker that's already there and has some guts in there already. And so there are some, skipping the live demo god favor here, but we're just going to jump through some commit history just to see how a worker can progress and how a project overall can progress. There are a few things. So workers are typically written in JavaScript or TypeScript, right? You can have your own build step. You can also write workers in Rust and basically any other language that can compile to WebAssembly. That's a topic for another day. We will just stick with TypeScript here. But there's one important file today, which is my little caveat to say, like, Wrangler is our workers build tool and deploy system. And Wrangler right now is undergoing an active 2.0 release cycle. And so some of this may change by the time this records, but it's more or less the same because Wrangler 2 will have some amount of either backwards compatibility or an easy migration path. So just put this out there. So in today's version of Wrangler, we have a Wrangler TOML file, which has typed JavaScript, will accept a bunch of, account related IDs. These are okay to be publicly shared and stuff, but like, we're not going to deploy for today's walkthrough. But because it's typed JavaScript, we can specify our own build command. So we're just going to run npm run build, which we'll see in a second. And then we're telling the backend, the workers backend, what kind of worker we're writing. This is important because traditionally workers were only written using the service worker syntax. So that would be something like a runtime service worker where you would have in an actual service worker or like sw.js file, you would have add event listener, fetch, and then on that fetch, do something. And so if you look back into the days of SW pre-cache or, today the active project is Workbox, right? These are all runtime service worker client libraries that will make sure your client assets are like in the browser already ready to go, work offline, those kinds of things. So workers follow a similar model, but Cloudflare has kind of had a evolutionary next step where we now use, we've foregone the service worker syntax. So there's no more add event listener. And instead we're using ESM or ES module syntax. And so we have, an export default at the root of our entry file. And so there are some like syntactical differences with this, but we're basically leaning into the fact that JavaScript developers today are already using ESM and they're already organizing their code in a way that has like their own like module utilities or using libraries that use modules, these sorts of things. So we're not cut away because service worker syntax is still supported, but we've elected into this modules format. So that's what all our demos today will be looking at.
Okay.
So with that, we have a worker, right? So we have this index.ts file. I don't know how familiar both of you are with TypeScript or people at large are, but definitely my recommended way to go because it is giving, strong type checking along the way. But just like the service worker syntax or service workers in general, you're working with like web API primitives. So this rec here, this request is the web API request. And we're dealing with requests and responses. So like here we're returning a response, and these are exactly the same thing you would find in the browser, right? Like you can more or less type this code in your browser today and it will work. There are some Cloudflare specific things that won't work, but that has nothing to do with request response. So for this demo, it's actually a Stripe official demo. We'll check it out in a second, but the demo, we're looking at the API endpoints where we want to look up, find existing checkout sessions, and we want to create a checkout session depending on the endpoint that comes in. So we have a request. Requests always have a URL associated with it. Again, standard spec request interface. We use the URL web API to get a path name, and then requests also have methods on there. So we just use the combination of the two to figure out where we are, right? Like basic manual routing here. Return a 405 if it's not a post, a get, or a head. Return a 404 if that's something else entirely, right? Something's going on.
Okay. So question for you then. A couple of questions I have for you. So does Cloudflare itself provide any scaffolding to create these projects? Like, is there a Cloudflare CLI where I could do Cloudflare new worker, or was this pretty much? Did you just kind of just create this from scratch?
So I created this from scratch because really the bare bones is so much for live, skipping the live demo gods, right? Like we can do export default, async, fetch, rec, and CTX. We'll get into those in a second. But like return new response, okay. And this is a valid worker, like just as this is. Like, of course, we don't do anything with the request, and it's very minimal. But like we are accepting a request, in this case, ignoring it, but returning some response at the end of the day. So we are obviously not making use of anything that Cloudflare offers, but you don't need any fancy tooling to get going. You don't even need to use TypeScript. But we also have an in-browser editor, like a REPL-like system that you can access through your Cloudflare account, and you can write this code there and deploy it from the dashboard directly, and it just works.
Yeah, I think this is really good to see, because what I'm looking at is 5 lines, probably less than 5 lines if you wanted to use Lambda functions, but you have like less than 5 lines of code to actually get started to create a thing. And as it is right now, like you could deploy that up into Cloudflare, into workers, and it would just work, right? It would start accepting requests,
right?
And that's it,
right? The only thing you really have to know is the Wrangler TOML stuff. But again, this stays the same. These 3 are required, and the rest of this can disappear. And this is the bare minimum Wrangler TOML file. Or you can skip the TOML entirely, the TOML file entirely, and deploy it through the dashboard, which is what I did probably for my first year of Cloudflare Workers usage, because it was fine. Like you can see the code you're using because it's just valid JavaScript. And of course, you skip version control if you're doing it that way. But Cloudflare also has a REST API where you can attach Terraform yourself or whatever it is you want to do, right? Like the point is you don't need to buy into a massive tool set before you even write your first line of code. Like you can do whatever fits and works with your existing solution, or pipelines, and just get going.
Okay. And I guess my next question for you now, so back in that index.txt file, so it looks like you're just getting raw requests and responses back. And so now you're having to do just a little bit of work to like parse the path. So then you say, based on this path, execute my conditional logic, like do this thing.
Right.
And you kind of do that yourself a little bit. Is there, or are there any frameworks or anything of the sort that you could use with this? Like, could I stick Express in this, or some middleware or something of the sort in there to kind of help me do this? Or is that not the case?
Yeah. So you can use any code, more or less, you want within a worker. So like I've kept it very local, like just using local files here. But there are because workers themselves are not a different runtime, right? Because again, it supports all of the service worker APIs, but there is basically like a mini ecosystem of packages specifically meant for workers or the worker API. Right, so like we're seeing a lot of packages that are meant for workers, but also support like browser service workers, and also support Dino, because like they're all more or less sharing the same primitives. So if we have time, we can get into one that I wrote called Worktop. We can see some like type interfaces coming from Worktop now, but there's IDI router. Why am I blanking? I've written one years ago called Shrouder, and it was initially a Node API. A node router, but all these things work. And so if you do want to use something like Express, this is actually a good segue, you could bring in the necessary polyfills to support it. So to use Stripe today, Stripe is traditionally a Node.js package, right? Like Stripe has done a lot of work to support the web primitives, and we at Cloudflare are very thankful for that. But there are still a couple of things here and there that Stripe may want to use. And so we just have to provide a polyfill so that code exists, even if it is unused, but just to make Stripe's dependency chain happy. And it works totally fine. So like we can see that here. So and for Express users watching this, you can treat the Stripe SDK as if it were Express. Like it's gonna work as well as your polyfills allow it to work if you're trying to bring Node applications directly over. But I would very much invite you to look at the existing ecosystem because it is new. And so like there are a lot of stuff that's been cut away that isn't really necessary in a workers universe. And at the same time, it's specifically meant for the workers runtime and runtimes like it. So it's actually, it's actually meant for what it is you're trying to do. But in any event,
so it's not like, so it's, it's not necessarily, this isn't Node. This is its own kind of runtime in a way, right? In the same way that like Dino is its own runtime. And so you got to think about it as its own kind of ecosystem to a certain extent. Yeah, well, not necessarily, but it has some things that were built with it in mind.
Right. Like you can basically think of writing worker code as if you're writing code for the browser. Because most examples, like again, this code right here, yes, it's TypeScript, but this function works exactly as is in the browser. Same with all of this that we're looking at here. So again, we're now using the Stripe SDK, and sure, I have some of my own like personal wrappers and stuff around it, but like I am using it the exact way that Stripe documentation pages tell me to use it. So we initialize a new Stripe thing. This is the only Cloudflare specific item here, and we can get into this in a second, but this is how we are passing in a Stripe key. And if we didn't want to do that, right, we can inline it directly, which is not recommended, of course, but we can pass that in directly, and that would make this code completely agnostic to the runtime it's using. It would just be a matter of whether or not the web APIs are supported. So I think that's probably a good time to actually talk about what the heck these bindings things are.
Sure. But before you do that really quickly, because I have a feeling like this question might be related to what you're talking about. Over on YouTube, we have some folks that are hanging out with us. One particular user, I'm going to say their name is Taiwu. I apologize if I'm not saying your name correctly. So this individual is saying, I've used Cloudflare Workers to create a CRUD API with Mongo Realm SND, right? So I'm guessing one, that's props to him. But then also he's saying, hey, Luke, I'd like to ask if there's a way to use send email package, like SendGrid and things of that nature with workers.
Sure. So again, that comes back to the polyfill thing. If you're trying to use SendGrid's existing Node SDK, right? So I will pull from personal previous experience. Like even before Stripe was really compatible, like again, you guys at Stripe have done a lot of work to allow this to even work at all, because there was a lot more node internals that could not be polyfilled, and you fixed that for us. Thank you. But there are still packages like that. So I don't imagine SendGrid would be one like that. But for something like SendGrid, you could just add a polyfill that include polyfills that would provide the, where am I going here? Would
like
provide
that necessary plumbing to make that stuff work.
Yeah. So like what Stripe does basically under the hood, and you guys know this better than I do, Stripe is basically sending HTTP calls to the REST API because you guys have an amazing REST API, right? Or or a GraphQL API if you want. But so like, Stripe has to do somewhere like under the hood, like require HTTPS, require HTTP, right? And like it's using those things which are Node internals. And so polyfills at build time are going and it's like, well, hold on, let's put that back. Hold on, this is actually going to be like polyfill HTTP, and this one will be like some other package under the hood, right? So like it's redirecting these required statements to something else that actually works for the runtime. So that's just like build config magic. And for this particular project, that's all happening here. So this worktop config file is just a builder thing. It's actually a wrapper around ES build, but it's pulling in this existing polyfills package that has all of those common. HTTP should have this code. HTTPS should have this code. Like the URL native module should have this code. And it's like replacing it with web or like browser compliant code replacements. And so like, that's all I did to get Stripe to work for this demo, is just import this thing. There's probably 2 polyfills that actually get used, but the point is I don't have to worry about it because it works. So back to SendGrid, this will probably work just the same because SendGrid is just sending HTTP requests to the SendGrid API. In a situation where that doesn't actually work, you can do what I've been doing for years as like an early Workers adopter, and I still like personally like prefer to do this quite often, is to send those HTTP requests manually to the REST APIs. So like Stripe has an amazing REST API documentation. So to SendGrid, actually, I do that. Actually do this approach for SendGrid, but you just look at the REST documentation and send actual fetch requests to those endpoints. So in this case here, you know, we are using the Stripe API, but we can do something like await fetch, whoever it is. And like, yes, fetch actually works because again, we are using web standards. So this will be like headers. If I can type, great, thank you. And this will say, you know, your content type, whatever, and then your body is something like JSON stringify, whatever. And it's like you can send stuff manually this way. And yeah, it may look a little verbose or whatever, but you can then pull in you know, some other client as some other third-party package to produce these fetch requests for you, or like write your own abstraction, whatever it is. But like the point is you can easily write browser code inside of a worker to do the things as a last resort if that's like your preference, or you can just try the polyfill approach to get these third-party SDKs to work out of the box.
Gotcha. And again, just for folks, because I know we have folks that pop in and out sometimes, just to be clear, that's the case because like you mentioned not so long ago, that this thing isn't exactly Node. It's JavaScript and it's a JavaScript runtime, but it's not specifically Node. And so because of that, there's some things that you have to attach onto it to get it to work. But other than that, you know, one of the reasons that you all chose this is because of how quickly this thing executes, which is one of the main benefits, right?
Right. So it's not Node, and the closest thing you can compare it to, if it helps your mental model, is you're basically writing browser code that happens to run not even in a server, but run globally at, you know, 300 plus locations around the world as if they were servers.
Got it. That makes sense. Okay. Cool.
Cool. So yeah, I don't want to spend so long on the actual Stripe code because this is your boilerplate Stripe code example, checkout example. But
that code did look familiar.
It is an exact. It's a copy paste. So the only thing I've changed is this part, which I'll get into in a second, and I've pulled it out into these methods that I named create and lookup. But you know, maybe one thing to note here, like response.redirect, yet again, this is a web API primitive. This is a static method that exists on the response class itself. So Stripe code, Stripe usage as is, no changes. So now what the heck are bindings? Bindings, so both create and lookup are taking these bindings thing. Bindings are coming in through here. So checkout lookup takes the request and this EMV, and so does create. So this EMV here, if we look at the definition, is how we actually pass in the Stripe API key. And so we can see that again up here, where like we're actually calling it here, and thanks to TypeScript, if we try to call it something else, it's like, hey, wait a minute, wrong thing.
Thanks.
But this is how we're passing through our Stripe API key variable. So we look back at the Wrangler TOML file, and like we have this vars section. So this is how you can, you know, have the same code and just pass through different environment variables, or it's not going to be applicable today, but we have another product called Workers KV, which is a key value store, hence the name. But those KVs are, let's call them databases, but those databases, you can pass in different ones for a staging worker or a production worker, right? And so just like you guys do at Stripe, you can have a test key for staging and the live key for production. And so like, instead of changing it in the code, you just change the variable value at deploy time. But that gets passed through this EMV or bindings object, whatever it is you want to call it, gets passed through here along with the requests and a context that, again, we're not using today, so we don't have to talk about it. But we're effectively passing around this object of environment variables where needed, so that we can be explicit with what we need when we need it and like what we do with it. So we pass in the entire bindings to our checkout, lookup, and create functions, and each of those, if I can expand it, we'll call this setup method so we actually get the Stripe SDK when we need it. So that setup function takes the bindings object, which again has our Stripe API key in it. We return the new instance of itself. According to the Stripe documentation, we have to create a fetch HTTP client, and this uses the web API fetch, and we're good to go. So that's it in this code. With that, we don't really know how we're on time.
Well, so now we got to deploy the thing, right? So
Yeah.
So now this is on your machine. How do I get it on those servers? Like, is there a command for that, or do I like zip it
There
and
is.
upload it?
I don't actually have like this machine set up to do it, but it will be Wrangler publish, right?
Okay.
So like Wrangler publish looks at the TOML file that you have and attaches your name, your account ID, whatever. And if you have a build step, it will run the build step and upload the output directly. So we can run the build here, right? Yarn build, it invokes my worktop builder system. It built the index file that we were looking at and produces this build output file. So if we look at the build output file, we see this very long thing with all the polyfills necessary, blah, blah, blah. Scroll to the bottom, we can start seeing some familiar stuff. And I did check out a new commit already, but we can see if API checkout, and it's a get, call lookup. If it's a post, call create, otherwise 405, otherwise 404. So like this is our code, and it's just brought in a bunch of stuff where necessary to do it. And the commit I checked out. So I imported front-end assets so we can actually serve front-end assets now and have something to look at. And start this up locally in a dev server here. And so here's the demo, right? So this is the Stripe API demo. All that's been added between the commits is a directory of front-end assets. So some CSS files, a couple of HTML files. And because this is a hand-tuned worker, we define those routes ourselves, right? So if it's a get and the path is canceled, serve the canceled page. And that was imported as a string up there. If it's a get and it's the home page, serve the home page, blah, blah, blah. So that's what's happening here. So like,
Interesting. One quick question.
Yeah.
We've been asking you so many questions. So I know there's worker and there's pages. So like right now, this is not pages, right? This is workers grabbing an HTML file and then sending it in a response, essentially.
Yes. So this is what life was like before pages, right? And so this is going to be our segue into pages. But in order to serve front-end assets, we very much can, right? Because it is just a response, and it's a difference of content type and the stuff within the response, right? So like our reply helper here is taking some string and sending down a status and some headers stuff. And so all of these front-end assets that our workers now serving, they have their own content types. There's a bunch of HTMLs here. We have a favicons, so we change that. We can tweak, cache control, cache control headers, public. I love typing live. Let's do 30 seconds here. So that will update the dev server. And now if we reload this, response headers expand, we can see public max age here. Right, so like we can do whatever we want within the worker because again, like we have full control over the entire request response lifecycle. Yeah, but like I can remove this route now, which is what it initially was. So like I removed the home page and now we got the 404 response because we don't have it attached up anymore. Let that go back. But so like it's very functional, and I still have sites personally that do it this way. But if you want to automate it, right? Like here it takes us to the checkout example. Like it's all working, it's using our stuff, great. But if we want to automate this or automate the front end asset part of it, we should start looking at pages, or maybe start looking at pages. Again, it's up to you and your preferences. And so that's where this editor now comes in. So it's more or less the exact same code. Like it's the same worker code, right? Like maybe I've moved some of the pieces around a little bit, but basically if it's not API checkout, step back. Now the worker portion, step back again. Okay, so we look at it from the static asset point of view first. That's trash. So that we have this public directory now with an indexed HTML. Let's actually look at these side by side. We have indexed HTML from both of them. Again, I just copied these over from right to left. So like they are the same files. They just now exist in a public directory because of old school conventions, whatever. CSS files are in there too. And so at this point here, let's do serve public dev. Let's look at this right now. So there's this local server on that directory. Like it looks the same, right? But there's nothing going on. There's no endpoint to handle this API checkout request. So that's where we need a worker part to come in. And so that's where we have our worker code still existing. So for this, we have a worker being written, and it's, again, more or less the same code that we were just looking at, where we only want to do stuff on this API checkout route. If it's not that route, 404, because again, we are only doing the dynamic backend stuff now. If it's a post, we're going to redirect it to the checkout create method. If it's a get or a head, whatever, if you want to be like perfectly ideal, compliant, whatever, we look at the lookup method. And so those are still the same, where we are using Stripe as documented in the documentation everywhere. So like it still works exactly as you would expect. So if I clear all that, we, for time, I probably want to start attaching this now, but I'll walk through what's going to happen. So we're still using a worktop builder. We still have Stripe loaded, as we saw, and we still have a build command. So in order to actually build this, we have a public directory ready to go. If we had some Next.js project or some whatever, like we could produce this public directory by some other means if we want. But right now we have static assets because that's what the Stripe demo gave. But we still have a build step for our worker itself to convert this TypeScript and like produce the module worker format. Great. What we do with this is Pages has two ways of attaching dynamic behavior. The first way is to use a functions directory, which automatically routes requests to endpoints. We're not going to do that today because that's a whole like another hour session on its own. But basically, if you're familiar with something like Next.js or SvelteKit or Remix or all of these, universal meta frameworks, there's a file-based routing system with its own particular syntax. And in a Pages context, we can do that for you within a special functions directory. And if that exists, we piece together all of those routes, all of the file tree based routes, and produce a worker for you right? Like it's a very sleek, very elegant way to just write the one or two endpoints that you need and be on your way. The second way, the more advanced way, is to write that entire worker yourself. And I'm doing that today because we've already done that because we wrote a whole worker initially. So the easier way to migrate is just to take the bulk of our worker that we've already written and just stick it in an underscore worker MJS file in our public directory. So gotta show what that looks like. That's where our builder is putting it. So we built this underscore worker file and we placed it inside the public directory. And so when Pages is deploying the public directory, it's going to say, oh, there's a worker here already for us to use. So we're just going to use it. And then that worker is invoked all the time. So it's, how else do I say this? That worker is assigned to your Pages project automatically, and it will handle all the stuff that you want it to do. But when compared to I don't like saying old school because it's still very viable, but the previous approach or the old school approach is you just don't have to deal with the front end static asset file serving manually anymore. So there's kind of a lot going on. So I just want to show like how you actually like hook this up now. From within the Cloudflare dashboard, there's a Pages section. You have to hook up GitHub and stuff, which I've skipped over because I'm already hooked up. And there's a build command, right? So npm run build, that's to invoke this stuff that we just ran. The build output directory is public because that's where all of our stuff that we actually care about lives. And root directory we don't need, but there's environment variables. So environment variables, as we've seen in the previous example, we have a Stripe API key to pass through, right? And in our Pages code or Pages worker code, we still are making use of that Stripe API key here. We could move it into a setup function like I had before, but in the Pages scenario, it's injected as a build variable here. So I'm going to paste this in for us really quickly. And then I always like to do this just as a longevity thing, but save and deploy. So this is going to attach to the GitHub repo, which I have this code we were looking at here. We have our worker, and we have the public directory, nothing different going on. When it initializes the build environment, it just, makes sure it has everything up to date. The build images, node versions, blah, blah, blah. Clones the repo, builds the application. This is where you can spend, 30-ish seconds, 24 seconds today. That's great. Runs the build command that we provided, npm run build. You can see my command's output. It detects like, hey, there's no functions at the /functions directory, which is to say it's going to use that worker file that we provided. But success, your site was deployed. Great. And so if you look at it, we will see the site deployed, ready to go. And it has, did I do it incorrectly? I probably did. Stripe API key. This is live demo, guys. Great. Well, I have it deployed here already, right? It's the exact same code.
Good old back hosts.
Just for time's sake, I did this yesterday, but it's the exact same everything ready to go for us. So I can go foobar, but 42, it's 42, 26, 1, 2, 3, foobar.
Oh, it's going to yell at you about the email thing.
Yep, it's okay. See that. Oh, thanks. So it successes or redirects you back to the success page within the Pages application with the response. And this is all just part of the official Stripe demo. So I can restart demo, takes you right back to where we were and Ta-da. So the benefit here, right, yet again, just to highlight, is we can still have a clear separation of back end and front end. This worker code is kind of the middle ground between the worker's way of doing thing and the page's way of doing things. But the point is you can very much have that middle ground and have something fully functional when you are migrating an app, or you want complete control over your routing logic for pages and for workers. And if you want the easy, framework-ish feeling way, you can do the functions directory and do the same stuff in that way. So like there are a few ways to do it, but pages itself, I will show this part. We'll automate the deployments as we saw, and give every deployment a unique hash over time, so that as you continue to develop your project over time, you can always instantly roll back. I only have one build here, but you can instantly roll back to previous deployments, or have deploy previews, what we call them, so you can see what you can see your work. Let's do this actually. Sure. Color. CSS. Let's just change this to like green and hope it sits. So look at again. Do something like important. I don't know your guys' CSS.
Yeah. It's I don't think it's gonna.
Okay, well, let's change the by thing. So we can say by 1, 2, 3.
Yeah.
That one we will see. Great. Okay.
Nice.
Would be a public index, change text color. So we'll give that a second to get going, but like we will watch pages go in the meantime. We can already see it, like it saw the push. And so this is because the repo is attached to pages. Pages is watching the repo all the time. And if we watch the build go, it's already in progress. I will have this going here in the meantime.
So you have your CI/CD. All you have to do is you just need to push to GitHub basically, and it'll do its thing.
Exactly. So pages is still like live broadcasting the update. It was successful. This URL right now. So by 1, 2, 3, this is tied. Close this. Oops. Lost the tab. So this URL is tied to this PR, and it will update as this PR changes, which is great. But if I go ahead and squash this, which I want to do, so I can show the rollback stuff. Let that go one more time. It's marking it as production build now because it's on the main branch. Whereas this was a great preview because it was not the main branch. So that's the two distinctions that we have.
So quick question for you then. So you showed us how to do it through GitHub. What if I don't use GitHub? And what if I use, I don't know, GitLab or Atlassian or Azure DevOps or a thing? Like, is that configurable?
I know we have GitLab support now. I think Bitbucket is on the way, but also on the way is Pages will allow you to upload the assets directly. So nice. you can have your own CI/CD, self-hosted, whatever, right? And as your final step, you are uploading all the built assets directly to Pages, and it will accept it and like count it as a full build
deployment unit
and take it from like what's effectively like a zip dump into like the Cloudflare network. So basically skip all of this and do just this part for you.
Nice.
But that is on the way. I think that's going to be, don't quote me on this, but I think that's this quarter or next quarter, but it's very much a high priority for the Pages team. Cool. So that went, let's refresh the page, just make sure everything's up to date. We look at the base URL, like the latest main branch and now has the by 1, 2, 3. And the way Pages works is everything is versioned, right? So this URL is currently using the 489 version build, which is the latest build here, right? This one. So if we click on that, we can see the exact same site by 1, 2, 3. But the previous site, our initial one, still exists. It's the C9F7 address. So this is still existing, and it does not say by 1, 2, 3. It's the original by. And this is great. This also works for like preview deployments and stuff. But this means that as your project develops over time, you can always see like what changed over time. And because Pages also has the backend tied to it, it's not just a visual difference over time. It's like a backend functionality over time. So this C9F build has its own worker, and it's a completely different worker than the current 489 build. So you have version control for your workers as well as for your assets. And then the final little bit here is if I want to go back to the by address, I'm going to keep this build here. So the demo Stripe page is the root one, right? Currently it says by 1, 2, 3, initial deployment. Click that button. Yes, roll back. And if I just refresh the page here, within about like 30 seconds or something, it will update globally. Make sure it says that. Okay, so it does say green production. It is ready to go. I may have, there we go. So it is live back to the original version using the original worker code as well.
Nice. So is it fair to say that workers and pages are kind of running on the same infrastructure? Is that fair to say? And then if I have a worker, I could easily turn it into a Pages app just by like adding a folder and putting some assets in there. Is that fair?
Exactly. So the folder was just me wanting to use TypeScript still, but like I could skip all this, right? And I could have export. You
just write straight JavaScript in public.
In an underscore worker MJS. And this is that option too, if I didn't need...
if you didn't want to do TypeScript.
If I didn't need TypeScript, or if I didn't want full control over all the routing, I can opt into the route that we didn't have time for today, which is this functions directory. And in here, I can have, let's say, a subdirectory called API. And then now there's a file called checkout.js. And like I can start exporting route handlers from here. So const.
Okay. And then would the route relate to the folder? So now would that respond to /API/checkout?
Yeah. So this will be post API checkout handler.
Got it.
Okay. So this is the file-based routing thing. There's a lot to go into as to like what actually is passed through to this function and how, like, because we have middleware support in here too. So there's a lot of like routing bits and pieces that fall into this. So I wanted to avoid that today, but there's a whole framework that goes in that is very powerful. And it's a way to easily piece together applications, again, over time, or share bits and pieces of your code or of your backend applications over time. So there's also this concept of Pages plugins where we actually do have a Stripe plugin that has all of, I think it's a Stripe checkout plugin. And if not, you can create one, but you can have all of the code for a Stripe checkout series like we just did, import it where necessary, right? Like let's add Stripe from foobar Stripe, like whatever it is. And then where you want to create checkout sessions, you like invoke the Stripe. This is all like pseudocode now, right? Like create checkout thing, or maybe the plugin like just has you do something like this. So this is the request handler, and you're just importing pieces of your code from like, your shared company registry, whatever it is. and you can stamp out multiple pages applications using the same request handlers without having to worry about, writing the entire worker file at once.
Got it. That makes sense. Okay. Yeah, this has been really great. So me for one, like I said in the beginning, I've only ever thought about Cloudflare as like the DNS place. So it's really cool to be able to see some of these other features and functionalities that are kind of built in the platform. And as we're kind of looking through the chat, some folks were asking about the key value store and stuff like that. And I know you had mentioned that was also an option too, and you could bring in that package. So I would say for folks that are interested, definitely head over to the Cloudflare documentation. Check out workers, check out pages, check out the DNS because we all love the DNS, and all the other cool things that are inside of there. I do have one last quick question that I do want to make sure I ask you before we go. You mentioned earlier about WebAssembly and that Cloudflare workers essentially could run anything that's WebAssembly based. Is that correct?
Mm-hmm.
Right. So if I had a Rust thing, like you said before, I could do that. If I had obviously JavaScript, but then any other language that compiles down to it. Is there anything specific that module, I guess they call them modules, that thing need to do? Like, does it just listen for HTTP requests, or like what needs to happen if I decide to compile my Python app into WebAssembly and like throw it up in Cloudflare? Like, how does that work?
I can't speak to Python specifically, but if you want to write, so there's two things you can do with WebAssembly. You can have an existing JavaScript worker, and it can pull in a WebAssembly binding in the same way that we had environment variables as a binding. You can have KV, namespace, database, whatever you want to call it, as a binding. We also have durable objects as bindings. Like, you can pull in a WebAssembly module as a binding and invoke it where necessary. So the only thing that comes into play there is size, the size limit of the WASM module itself.
Yeah.
So if you, something I've been like playing with, and I've seen other people do it, but I've wanted to spend more time with it, is to, compile SQLite into like WebAssembly and like load it inside of your JavaScript worker. Like, really cool. And like, you can, like, there, you do start brushing up into the size limit of it, and that's where the sticking point is. But if you look, there are a lot of projects on GitHub where people are trying to like blow away as much of SQLite as possible just to get SQLite below the threshold. That's option one. Option two for WebAssembly is to use something like Rust or Python or whatever. And I think all you have to do is export the fetch handler in the necessary way, the necessary interface, so that like the request information can be passed through. I haven't personally done anything like that, but there's a very active workers RS repository on the Cloudflare GitHub specifically for Rust authoring workers.
Okay. Cool. So for folks that are interested in learning a little bit more about like how that works, like you said, like head over to the Cloudflare organization on GitHub, and then let them know what you think about it.
There's also documentation on the DevDoc site, so developers.cloudflare.com, and there's a decent amount of tutorials and stuff on specifically writing workers with Rust.
Cool. Charles, do you have anything that you wanted to hop in with?
I mean, I'm just really impressed with how cool this platform is, and that SQLite that you were describing is also really, really exciting. So, like, I guess if you were able to get it to work, then you would have SQLite deployed across 300 different. Okay, is that essentially what it would be? I mean, I've heard of projects to try and make a SQLite that's distributed, for whatever reason.
It would, yeah. So if we want to spend another like minute or two on this topic, just to like not send people off in like wild goose chase. So when you compile SQLite down into a WASM like state, there's no data in there yet. So you still have to worry about loading data into the SQLite instance before it can do anything. And so that's where something like workers KV comes into play. And I've seen this where people have this bare minimum SQLite going, do basically a stream from workers KV to load up that SQLite instance with data, but that can be costly, right? That can be latency costly because you're streaming a whole bunch of data potentially into your thing. So the workaround I've seen, and we haven't talked about this, is to use durable objects, which are standalone isolates. So like instead of having your worker everywhere by default, a durable object is a worker with state and it persists in one location over time. So you can direct requests to this identifiable, AKA the same durable object over and over again, as if it's a traditional Node.js server, right? Of course, it's much smaller, much faster, blah, blah, blah. And that durable object loads up the SQLite with the data and it just keeps it there, right? And so it remains the standalone mini server with the data in there ready to go. And it becomes this more or less a proxy in front of SQLite so that the workers talking to the durable object can get the stuff that they want. And it's, again, the way durable objects work is you can have multiple copies of this durable object, each with different names, each with different states, which means that if you wanted, you can have, each customer, each with its own durable object, each loading up their own SQLite WASM stuff with their own customer specific data inside the SQLite instance. And each of those durable objects are proxying customer specific information per person. So it can get complicated, right? But at that point, you're probably better off just using durable object storage and state directly, which is for a JavaScript developer, just like using a normal map or an array list. So it's a very nice API within durable objects. Again, we didn't get into it today, but you can do the exact same customer management system without having to worry about something as complex as a WASM binding thing. But if you want, it's there. It's just it's choose your adventure,
Got it. Yeah, we got one of these comments from Steve McArdle. He said, "Why not use Redis then?" And as you build for the SQLite situation, I think there's a clear reason for why you might do it with durable objects.
There's size, but at that point, if you wanted to use Redis or need to use Redis, just send requests to a Redis cluster directly, or because again, every worker and durable object knows where it is in the world. So you can have your own geo redirecting logic in there and send it to the closest cluster or the customer specific cluster, whatever it is, and deal with it there within native Redis with its own monitoring and all that stuff. So if you can whittle Redis down enough below the threshold, by all means, but that's kind of, mad scientist level of stuff. Just use Redis directly, in my opinion.
Yeah, Steve agrees. You start out there. Okay, we are probably kind of way over, but this is fascinating. It sounds like there's so much that Cloudflare is doing that solves a variety of different problems. Yeah.
It's an entire platform. You can build, we don't only just scratch the surface, but it's the amount of products in it. It's an entire cloud platform. And I've been calling it the Cloudflare stack for years, to the point where I think Cloudflare is now, or at least my team has adopted that term. So nice. I'm happy with it. It is very much the Cloudflare stack.
Nice. That's awesome. So Luke, if folks want to reach out to you or your team, other than GitHub, what else would be a good option? Do y'all have Slack channels or Discord channels or other places that people could talk to you at?
We have a really active Discord. I think it's workers.community is the short link to it. But it's linked throughout the docs and you can easily find us. Also active on Twitter, both personally and the Cloudflare account. So if you want to get specifically to a Cloudflare community member on Twitter, we have Cloudflare developers, and you can go that way. But yeah, we're all available. We're all knowledgeable. So just reach out to anyone at Cloudflare, and we're always happy to help.
Awesome. Well, look, this like Charles said, this has been amazing, and I definitely learned a lot about Cloudflare and some of the cool things that you could do, and then hopefully our audience has as well. Maybe we'll have you come back on in a couple of weeks, couple of months to talk about all the other new stuff that you've added onto it. That, I think that'll be pretty cool.
There's even a lot of old stuff we haven't touched yet. So I'm happy to.
So much stuff to talk about. Yeah. So much stuff though. But with that being said, this has been another Stripe Dev Chats. Thank you all so much for joining us. And make sure you join us again In another 2 weeks, we'll have another guest talking about some of the cool things that we can do with Stripe. Thank you, everybody. Bye.
Thank you.